Okay, so we're working on these worksheets here. This is lesson 14, says at the top of the paper, isotopia, stable and radioactive isotopes. Okay, so yesterday we reminded ourselves what isotopes are, right? Yeah, okay, so we reminded ourselves what isotopes are. They are atoms of an element that have different numbers of neutrons. Okay, so that's what we were working with yesterday. And just to remind ourselves, we were looking at these atoms of boron, which all had 5 protons, but some had 5 neutrons, some had 6 neutrons, but because they all had 5 protons, that gave them the identity of boron. So remember, protons give the atom its identity. All right. So we are going to look at this graphic here. And the first thing we're going to do is zoom in on it a little bit. Okay, and it says for us to use your periodic table to fill in the shaded boxes. So these shaded boxes here, and then answer the questions. So we need to look and see what this graph is about. On the x-axis, we have protons, the number of protons. 1 proton, 2 protons, 3 protons, 4 protons. On the y-axis, we have the number of neutrons. 0, 1, 2, all the way up to 8. All right, and so we're filling in, and they've already done hydrogen and carbon and helium for you. And they've put in hydrogen can have 1 proton and 0 neutrons. So that's what this square is about. And then they drew a Bohr model for you here. So it has 1 proton, 1 electron, right? Electrons aren't part of this graph because when we're doing everything but nuclear chemistry, we're concerning ourselves with the electrons. When we're doing nuclear chemistry, we're concerning ourselves with what's in the nucleus, which is the protons and neutrons. Okay, this square represents hydrogen 2, which means it has still 1 proton because that 1 proton gives it the identity of hydrogen, but it has a mass of 2. So this top number is the mass number, meaning how massive is it? How many protons and neutrons does it have? And then here's the drawing. 1 proton, 1 neutron, or actually this is the proton. 1 proton, 1 neutron, that gives you the number 2. And it still has 1 electron because that's not going to change. All right, and then here's hydrogen 3. You have the number 3 on top, that's the mass number. That tells you how many protons plus neutrons we have. And then the number 1 on the bottom is the atomic number. That tells you how many protons, and it has to be 1 for hydrogen because that 1 proton gives hydrogen its identity. So here's that 1 proton, and there's the 2 neutrons, and again, 1 electron. Okay? And then helium, there's only 1 square for helium. Helium doesn't have any isotopes. Okay, it just has the 1 form of it where you have 2 protons, and then it has a mass number of 4. So if it has 4 particles in the nucleus and 2 of them are protons, how many neutrons does helium have? Whatever 4 minus 2 is, right? Okay, so 4 minus 2, helium has 2 neutrons. They didn't draw a Bohr model here for you, but if you were going to, you would draw 2 protons because it has atomic number 2. That's the number on the bottom. The top number is the mass number. That tells you how many particles are in the nucleus, the protons plus the neutrons. So you subtract those 2 numbers to get the number of neutrons. So this is different than what we were doing yesterday with the average atomic mass, because this is looking at a single atom. So if we're looking at a single atom of hydrogen, it could have 3 particles, 2 particles, or 1 particle in its nucleus. And of course, you're never looking, in real life, you're never looking at just 1 atom. You're looking at, moles and moles of atoms, so you would get the average. All right. All right, and then here's carbon. Go over the ones that are already here. Move this down a little bit. Okay, so carbon has 3 different forms, naturally occurring isotopes. Carbon 12 has 6 protons, and then 12 particles in the nucleus. 12 minus 6, that means it has 6 neutrons. Okay, so here's the 6 protons, here's the 6 neutrons. Carbon 13, right, so there's the name there, that's what we would call this. It has a mass number of 13, so that means it has 13 particles in the nucleus. 6 of those are protons. How many are neutrons? Whatever 13 minus 6 is, all right, that's 7. So here, the light colored ones are your 6 protons, the dark colored ones are your 7 neutrons. And then carbon 14 has a mass of 14, still has 6 protons. Remember, protons give the identity of the element, so it always has to have 6 if it's carbon, but it could have 8 neutrons because 14 minus 6 is 8. So this one has, again, 6 protons, those light colored ones, and then the dark colored ones, it has 8 neutrons. Okay. Questions about that? No? All right, so how do we fill this one out? Oh, and then something I didn't notice, or I didn't mention about the carbon. It is on this line for 6 protons, and they're all stacked up on here because all of these have 6 protons. But this one lines up with the 6 neutrons, right? Because 12 minus 6 is 6. This one lines up with the 7 neutrons because 13 minus 6 is 7. And this one lines up with the 8 neutrons, 14 minus 6 is 8. Okay, so what would go here in these boxes that don't have anything in them? All right, let me get a handy dandy periodic table. And who has 3 protons? We would look and see which of these elements is at, I'm trying to get it in the picture here. Lithium has atomic number 3. Okay, so atomic number 3, the atomic note tells you the number of protons, so that would be lithium. All right, so you would just write that down here, all right, Li. And both of these would, because they're both on the 3, Li. And then we would fill in the numbers here and here. So both of them are going to have 3 on the bottom because to be lithium, you have to have 3 protons. The bottom number is the atomic number, the number of protons. The top number is the mass. So it's the number of protons plus the number of neutrons. Number of protons is 3. On this one, the number of neutrons is 3. What's 3 plus 3? 6. Okay, and then this one, it's still atomic number 3, so we have 3 protons, but we have 4 neutrons. 3 plus 4. I just almost wrote the number 4. 3 plus 4 is 7. Okay, so it has a mass of 7 with the 3 protons, so it has 4 neutrons. This has a mass of 6 with the 3 protons and the 3 neutrons. Can we fit the little name in there? Maybe. So this would be, I might need to, I think I'll write it over here. Lithium 7. And then this one is lithium 6. Okay, so I'm gonna let you guys work on this for a little bit. So try to fill out these 3 boxes and then we will continue.